Hello everyone and welcome back to Destin Learning. In this video we're going to take a look at an introduction to AWS Elastic Load Balancing. Load balancing is critical for enterprise applications to ensure that the application remains responsive and can scale seamlessly. Let's go ahead and take a look at the details. AWS Elastic Load Balancing distributes incoming traffic across multiple servers, ensuring performance, availability, and fault tolerance. It supports EC2 instances, containers, and IP addresses with various availability zones, providing highly available and scalable applications. AWS Elastic Load Balancing, or ELB, is a managed service that distributes traffic across multiple targets, ensuring no single resource is overwhelmed. This improves fault tolerance and availability. AWS Elastic Load Balancing offers efficient traffic routing, dynamic scaling, and resource optimization. It acts as the entry point for all incoming traffic, routes requests to healthy targets, scales in and out as traffic fluctuates, ensures applications remain responsive during peak loads, and optimizes resource utilization. ELB improves fault tolerance by distributing traffic across multiple targets, ensuring high availability. If one target becomes unhealthy, it reroutes traffic to healthy targets, preventing service disruption. ELB integrates with AWS Identity and Access Management, or IAM, for access controls. It uses SSL and TLS termination for secure communication and manages SSL TLS certificates. AWS Elastic Load Balancers offer monitoring and logging through CloudWatch, providing real-time metrics and traffic analysis. There are three main types of ELBs to meet various application needs. Elastic Load Balancing, or ELB, offers seamless scalability by automatically adjusting to incoming traffic. It also provides cross-zone load balancing, distributing traffic across multiple availability zones to enhance redundancy and reliability. The Application Load Balancer, or ALB, is best suited for web applications and microservices. It operates at layer 7 of the OSI model, routing traffic based on content like URLs or HTTP headers. ALB supports advanced features such as path-based and host-based routing, WebSockets, and SSL termination. The Network Load Balancer, or NLB, is designed for high-performance, low-latency applications. It operates at layer 4 and handles millions of requests per second with very low latencies. NLB supports TCP, UDP, and TLS traffic, making it ideal for gaming servers and IoT applications. The Gateway Load Balancer is used to deploy, scale, and manage third-party virtual applications like firewalls or intrusive detection systems. It operates at layer 3, allowing transparent insertion and management of these applications, simplifying their integration between your application and the network. Target groups in a load balancer route traffic to specific resources like EC2 instances and containers. Each target group can handle different types of traffic. ELB performs regular health checks on targets, rerouting traffic from unhealthy to healthy ones for reliability. To set up an application load balancer, start by creating an Elastic Load Balancer. A listener monitors incoming traffic on a specified port and forwards it based on the protocol to the appropriate targets. To create a load balancer in the EC2 console, navigate to the load balancers under the Load Balancing section. Click Create Load Balancer and select the type and specify the name, VPC, and availability zones, and configure the security settings. To configure a load balancer, choose the protocol HTTP or HTTPS and port. For secure communication, and configure SSL certificates for HTTPS traffic. To create target groups, include your EC2 instances, Lambda functions, or container services. Specify health check settings like as HTTP response codes, timeout, and threshold for the load balancer to assess the health of each target. First, add your resources like EC2 instances and containers to the target group. Once registered, the load balancer will route traffic to these targets based on listener rules. Use CloudWatch to monitor traffic and latency. Enable access logs to capture request details for troubleshooting and traffic analysis. Sticky sessions, also known as session persistence in ELB, bind a user session to a specific target, ensuring a consistent user experience. ELB supports path-based routing, enabling traffic to be directed to different services based on the URL. For instance, requests to /API can be routed to one target group, while requests to /blog can be directed to another. The application load balancer supports WebSockets, which enable bidirectional communication, which is essential for real-time applications. Additionally, there are best practices for using Elastic Load Balancing. Using ELB for SSL termination offloads SSL TLS tasks, reduces instance load, and simplifies certificate management. Ensure ELB protection using appropriate security groups and network ACLs to control inbound and outbound traffic. Security groups manage traffic at the instance level, while network ACLs provide an additional layer of security at the subnet level. Ensure ELB distributes traffic across multiple zones for fault tolerance. Regularly review health checks to detect unhealthy targets. Enable access logs for auditing and troubleshooting. Offload SSL termination to ELB to reduce back-end load and simplifies certificate management. In summary, AWS Elastic Load Balancing is essential for scalable and reliable applications. It distributes traffic across resources, ensuring responsiveness and high availability. ELB simplifies load distribution, making it ideal for microservices and high-performance applications. Well, that's it. That's it for this video. If you like this video, please click the thumbs up button. If you'd like to see more videos like this, please consider subscribing to my channel. Thank you so much, and I'll see you in another video soon. Bye for now.